Hey guys, welcome to question MM298 of the Maths Methods Fortify study guide. Now this is an 11 mark question, so a pretty big one. So let's just start with AI, which is 3 marks. So we get this function that is f. Okay, so f of x is a function of x such that f dash of x equals x cubed plus 2x squared take x plus k, which is this bit here. Find the range of exact values of k for which the graph of f of x has 3 turning points. Awesome. So k is our horizontal translation, right? Because this is the end value, it hasn't got an x associated with it. This is actually our y-intercept or our translation, right? So what we're going to need to do is pretend for a second that k is equal to 0, okay? Because this k determines how far up or down we move the graph, okay? And if we let it equal 0, then we're going to be able to tell how far up or down we have to move it. So we have our cas in this question. So what we're going to do is sketch our f dash of x in our cas, and it is equal to something like this, okay? Because it's a cubic, this is our y equals f dash of x. Now our biggest thing here, guys, is that if f of x has 3 turning points, f dash of x has 3 intercepts, x-intercepts. So f dash of x is our gradient, so if that crosses our x axis 3 times, that means that our gradient on our original is going to have 3 times where it's 0, which means 3 turning points, okay? So our first thing here is to find out the range of kind of this bit here, right? Because if we move this graph up more than this bit here, we're no longer going to have 3 intercepts, and that means that we're no longer going to have 3 turning points on our original, okay? You might have seen a couple of questions like this earlier in the book if you've kind of gone through a bunch of questions. So what we're going to do is actually find out where these turning points occur, okay? And you'll kind of see why in a sec. We're going to solve this in our cas. So there's multiple ways to do this. You could just sketch this in your graph and graph trace this. That doesn't often give you an exact answer. So what I'm going to do now is actually derive this and find out where our turning points are. So that's our f dash dash of x, which is equal to 3x squared plus 4x take 1. And we know that that is going to equal 0 because that's where our turning points are going to occur on our derivative graph. According to our cas, that means that x is equal to negative root 7 plus 2 over 3, and x equals root 7 take 2 over 3. That's our first mark, okay? So our first turning point here occurs at negative root 7 plus 2 over 3, and this occurs at root 7 minus 2 over 3. Awesome. We don't know our y values yet, but we'll come to that now. So we found out our x values of these turning points, so now we need to find out our y values. I would just simply sub these into your original formula. So f dash of these two here, and this one, I'm just going to say this is our first x1, so x1. This is equal to 14 root 7 plus 34 over 27, and yes, we do have to do exact values because that's what our question told us. I'm just going to call this x2 just so I don't have to rewrite this, but you would rewrite this in your question. And that's equal to 34 take 14 root 7 over 27. Awesome. So that means that our y values are these, right? So this is 14 root 7 plus 34 over 27. Yeah, I know this is a bit cramped, so apologies for that. I didn't plan this very well, but we've got 34 take 14 root 7 over 27. Awesome. So there are our coordinates. If k equals 0, right? We've let k equal 0. That's our 0 point there, because we're going to have to move it up or down based on what k is. So this is our second mark, okay? So finding our y values is our second mark. And if our original graph has 3 turning points, it means that our derivative graph has 3 intercepts, okay? So we can move the graph up by this much, yeah? So 34 take 14 root 7 over 27 is a negative number because it's below the axis, which means that we can move it up by that much, which means we're going to move it up by negative that, right? So k has to be less than the negative version of this, right? Because if we, this is quite hard to explain. Imagine this was negative 3, right? We can't move the graph more than 3, okay? So we get the negative version of this, which is 3, because if we moved it up by 3, then it would be on the 0 axis, right? And we would no longer have 3 intercepts, we would have 2. We'd have 1 here and 1 here. So k has to be less than the negative version of this. Negative 34 take 14 root 7 over 27. So we can move it up by that much. We can also move it down by this much, so our y value here. So that means that k has to be greater than the negative version of this, right? And again, remember that this is the, like imagine if that was 5, for example, our y value is 5, we could move it down by 5 or less, right? So k has to be more than the negative version of 14 root 7 plus 34 over 27, which means that our range of values of k, yeah, I'm just going to rub this bit out. I know this is really confusing, probably because these numbers are a bit crazy, but I'm always here to answer questions in the comments below, so just hit me up if you have any questions. So therefore, k is between negative 14 root 7 plus 34 over 27 and negative 34 take 14 root 7 over 27. Awesome. And that's our third and final mark. Okay, so we don't include these values because if we included these values, we would have moved that down to the axis, which means we'd have one intercept there and one intercept here, which means that the original would have 2 turning points, not 3 turning points. So we don't include the edge values. I know this is difficult. Please hit me up if you have any questions in the comments below for this question. These numbers are a bit crazy, but we just have to deal with those sometimes. That's why we have our CAS. So let me know if you have any questions, but for now, let's move on to the next part. Part aiii is a 1-mark question, and it asks us to find the values of k for which the graph of f of x has only 2 turning points. Awesome. So if it only has 2 turning points, the original graph, f of x, that means that we only have 2 x-intercepts in the derivative function, right? So that means that we can move our graph up by this amount or down by this amount, right? If we move it down by that, this turning point is going to be on our intercept, and then we're going to have one more over here, so that's 2. If we move it up by that much, same deal here, we're going to have that intercept there and then that intercept there. So that means that our k value can be negative version of this, right? Because if this was 5, we would have to move that down by 5, so k would equal negative 5, right? So we take the negative version of that, so k equals negative 14 root 7 plus 34 over 27, and k equals the negative version of this. So negative 34 take 14 root 7 over 27, and that's it. So that's actually our first and final mark for this question. We really just have to recognize here that we want 2 x-intercepts on the derivative function, which means 2 turning points on the original function. That's awesome. So let's move on to the next part. Part aiii is a 2-mark question, and it asks us to find the average rate of change of f of x between x equals 0 and x equals 1 in terms of k. Awesome. So if we have our derivative function, a quick way of finding our average rate of change is actually by integrating this between the 2 values that we're looking for, right? So normally average rate of change, we would do gradient. So y2 minus y1 over x2 minus x1, which is, average rate of change. But when we have our derivative function, we can actually do our integral, right? So we can say that our average rate of change is equal to our integral between the 2 x values, so from 0 to 1, of the derivative function. So x cubed plus 2x squared take x plus k dx. And then we can just evaluate this normally, right? So we get x to the power of 4 over 4 plus 2x cubed over 3 take x squared over 2 plus kx between 0 and 1. Sweet. This is our first mark. And then from here, we can just evaluate these, right? So we get 1 to the power of 4 over 4 plus 2 times 1 cubed over 3, take 1 squared over 2 plus k times 1. And then all of these x's are kind of attached to constants, which means that when we sub in 0, it's just going to equal 0. So that's it for this bit, which means we get 1 over 4 plus 2 over 3, take 1 over 2 plus k. Awesome. Now we can kind of simplify this. So what we get is, in the end, actually, you know what, we can simplify all this to 3 on 12 plus 8 on 12, take 6 on 12 plus 12k over 12, and then we can simplify this to 5 plus 12k over 12. This is our second mark. So remember, we wanted the average rate of change in terms of k, and this is in terms of k, which means that's our final answer. So guys, that's it for part aiii. Please hit me up if you have any questions in the comments below, but let's move to part B. Part B is a 3-mark question, and it says the graph of f of x passes through the points -1, 13 on 12, and 1, -19 on 12. Awesome. Find the equation for the graph of f of x. Cool. So we know our equation for f dash of x, which means that our equation for f of x is going to be the integral of that, or the antiderivative of that. X cubed plus 2x squared take x plus k dx. Awesome. And we're just going to use this to find our equation. So from here, we can just evaluate this normally. So we get x4, or x to the 4 over 4, plus 2x cubed over 3, take x squared over 2 plus kx plus c, right? So don't forget our plus c on the end there, because when we're evaluating this like this, we always need our plus c, especially when we're finding equations. So we know that this goes through -1, 13 on 12, and 1, -19 on 12. So we have two unknowns here. We know this is f of x. We have two unknowns, and we have 2 points, which means we're going to be able to solve this using simultaneous equations, right? So using our first coordinate here, we're going to say that our y value, 13 on 12, is equal to this with -1 subbed in, right? So we get -1 to the power of 4 over 4 plus 2, -1 to the power of 3 over 3, take -1 squared over 2 plus k, -1 plus c. Awesome. So I'm just going to go back up here for a sec. So simplifying this, we get 13 on 12 equals 1 over 4, take 2 over 3, take 1/2, take k plus c. Awesome. And then we can simplify all this to c equals 2 plus k. And that's our first simultaneous equation. Now you could put these in your calculator, but I'm just doing this to show you what's happening here. So that's our first mark. Right, we've got our first equation, and now we're going to make our second one. So we know we've got 1, -19 on 12, and we're going to do exactly the same thing here. So we get -19 on 12 equals, and we're going to sub in 1 for x in our original function, right? So we get 1 on 4 plus 2 on 3, take 1/2 plus k plus c, right? I've kind of done that quickly, but we're just subbing that back in as we normally did with the other one. So from here, we actually get c is equal to -2 take k, and this is our second simultaneous equation. Now, we can see that our simultaneous equations here are both equal to c, right? Which means we can equate this, and that'll allow us to find k. So therefore, 2 plus k is equal to -2 minus k, and therefore k is equal to -2. This is our second mark, okay? So we've got our value of k, and we know that c is equal to 2 plus k, which means c is equal to 2 plus -2, c equals 0, okay? Sweet. And then from here, we then say, therefore, f of x is equal to x to the power of 4 over 4 plus 2x cubed over 3, take x squared over 2 plus kx, so take away 2x. And our c value was 0, so we have nothing on the end here. This is our third and final mark for this question. And that's it. So the biggest thing here is just to make sure that we include our c value. Even though it was 0, it was still important to include that because it might not have been 0. And if you didn't include c equals 0, if you didn't include your plus c on the end of your integral, you would have been incorrect. Or you probably would have got 1 or 2 marks for that. So that's it for part B. Let's move on to part C. Part C is a 2-mark question and asks us to find the area bound by the curve y equals f of x, the x-axis, and the lines x equals -2 and x equals 0. Awesome. So what we're doing is just finding area under a curve, which means we're going to be using our normal integral formula. So we get area is equal to our bound, so from -2 to 0, of our f of x, which is x to the 4 over 4 plus 2x cubed over 3, take x squared over 2 minus 2x dx. Sweet. And now we can just evaluate this. We've got our CAS, so we can use our CAS for a little bit of the working, but we still want to show as much as possible. So area is equal to, now we can just kind of evaluate this, and we can get x to the power of 5 over 20 plus x to the 4 over 6, take x to the 3 over, take x to the 3 over 6, take x squared from -2 to 0. Awesome, this is our first mark, right? So anti-deriving that is our first mark. And then we can simply evaluate this. So we basically sub in our 0 and our -2. Now 0 is going to sub in here to equal 0, right? All of these are going to equal 0. So we get 0 minus, and then we sub in our -2. So we get -2 to the power of 5 over 20 plus -2 to the 4 over 6, take -2 to the 3 over 6, take -2 squared. Awesome. From here, we get -32 over 20 plus 16 over 6, take away -8 over 6, take 4, and that equals 8 over 5 units squared. So because we're dealing with area, don't forget our units squared. But that's our second and final mark for this question. Guys, if you have any questions about any of this, as always, please hit me up in the comments below. But that's it for MM298. And thanks for watching, and I'll see you in the next video.